We proceed with the next process, which is the integration of hyperbolic functions. The table here shows the formula for the integration of hyperbolic functions. So the integration of sine hyperbolic of x is equals to cos hyperbolic of x. The integration of cos hyperbolic of x is equals to sine hyperbolic of x plus c, and so on. So you can refer to this table in order to solve the integration of hyperbolic functions. Okay, try to evaluate the following integrals. A is the integration of cos hyperbolic square x dx, and the second one is the integration of x square sine hyperbolic x dx. So now let us try this integration of cos hyperbolic square x dx. So if you refer to the formula of the integration for the hyperbolic cos, you will get cos hyperbolic x equals to sine hyperbolic x. However, for this case, it is not cos hyperbolic x, it is cos hyperbolic square x. So we cannot directly use the integration. So, what we can do is we use the identity of hyperbolic functions, where from the formula we know that cos hyperbolic square of x is actually equals to 1 over 2 times with cos hyperbolic of 2x plus 1. So now you can see that it is in terms of cos hyperbolic of 2x. And now we can solve using the integration of cos hyperbolic of x dx. Okay, then the next step is to substitute this into the form of identity. So we can integrate 1 over 2 cos hyperbolic of 2x plus 1 of dx. We can take 1 over 2 out since it is a constant. So 1 over 2 times with the integration of cos hyperbolic of 2x plus 1 dx. In order to make it easier, we substitute 2x as u, where u is equals to 2x, and we want to find the du, which is 2 of dx. So dx is equals to du over 2. Okay, so for the first part, for cos hyperbolic of 2x of dx, the first part is 1. We can represent this as the integration of cos hyperbolic, where 2x is u and dx is equals to du over 2. Okay, then we have 1 over 2 cos hyperbolic u is equals to sine hyperbolic of u. Okay, now we have this and we substitute u with x, where here we get sine hyperbolic of 2x. Okay, now we have solved the first integration. Okay, we substitute this back into the first integration. We get cos hyperbolic square x dx is equals to 1 over 2. The integration of cos hyperbolic 2x dx is 1 over 2 sine hyperbolic of 2x. And then another one is the integration of 1 dx, which is plus x. And all this, and then plus the constant of c. So next is we expand this, we get 1 over 4 sine hyperbolic of 2x plus 1 over 2x plus c. So this is the integration of cos hyperbolic square x dx. Moving to the next question, integration of x square sine hyperbolic of x dx. So here we have a product of two functions. The first one is x squared and the second one is sine hyperbolic of x. So there are two ways in order to solve this. It's either you can use integration by parts, or if you want to make more systematic, you can use tabular method. Okay, for both of this method, you have to determine from this function which one should be differentiated and which one should be integrated. Okay, so I have mentioned in the review on integration in week 1 where I use this LIATE. So whichever come first, okay, in this list should be differentiated. Okay, so here we have our function is in terms of algebraic. Okay, and the second one is hyperbolic functions, which falls under exponential. Okay, since our hyperbolic is based on the exponential function. So here we have our second as exponential. So now we can determine that our x squared will be differentiated and this sine hyperbolic will be integrated. So now I'm going to show you the use of tabular method. So here we have our u differentiation, and also here is the integration, and then the symbol. Okay, the symbol always start with positive. Okay, and here we have x squared. It is supposed to write as t over dx. Okay, and then the integration would be sine hyperbolic of x. So now we have to differentiate this x squared. It would be 2x. The symbol here would be negative. And then the integration of sine hyperbolic would be cos hyperbolic of x. Okay, so we will continue differentiate until we get the final answer, which is equals to 0. So here would be 2, and then this one sine hyperbolic of x. Okay, and then this next step is differentiate 2, where the result is equals to 0. And then integrate sine hyperbolic, which is equals to cos hyperbolic of x. Okay, now we can solve this. So I just write back the equation, the question. So the first one is this. So plus positive times with x squared cos hyperbolic, and then minus with 2x sine hyperbolic of x, and then plus 2 cos hyperbolic of x, and the last one is 0, so plus c. So this would be your final answer. Or you can simplify this, since we get here the same function, 2 plus x squared cos hyperbolic of x minus with 2x plus c. Now I want you to pause this video and I want you to do the exercise to evaluate the following integrals, where this integrals is the definite integral So your final answer should be in terms of a number. Okay, try this first out. Try this first, and then you can play the video to see the solution for these exercises. For question A, this is the definite integral where the interval is between 0 up to 1/2. So first, we solve the sine hyperbolic of 2x dx using integration by substitution, where we substitute u with 2x. We have u is equals to 2x. So our du over dx is equal to 2 dx. So our dx will be equals to du over 2. Okay, now we represent this integration into u sine hyperbolic of u. Our dx is now du over 2. So now we can straight away solve this, where the integration of sine hyperbolic u is cos hyperbolic u, and substituting u with 2x, we get 1 over 2 cos hyperbolic of 2x. Okay, now we have solved the integration of sine hyperbolic of 2x. Okay, now we know that the interval is between 0 up to 1 over 2. Sine hyperbolic of 2x dx is equals to 1 over 2 cos hyperbolic of 2x, where the interval is between 1 over 2 and 0. So we substitute x with 1 over 2 and 0. We get 1 over 2 cos hyperbolic 2 times with half minus with 1 over 2 minus with 1 over 2 cos hyperbolic 2 times 0. So we have 1 over 2 cos hyperbolic of 1 minus 1 over 2 cos hyperbolic of 0. So by using calculator, you will get 0.2715. So this is the last question. Okay, now we want to find the integration of tangent hyperbolic x, where the interval is from 0 up to 1. If you refer to the formula, there is no solution or there is no formula for tangent hyperbolic x dx. So what we need to do is, we know that tangent hyperbolic of x is equals to sine hyperbolic of x over cos hyperbolic of x. So we can represent tangent hyperbolic of x with this equation. So this will be tangent hyperbolic of x dx from 0 up to 1 can be represented as sine hyperbolic of x over cos hyperbolic of x dx. Now we can use the integration by parts. Integration by substitution. Okay, now we substitute u. We let u equals to cos hyperbolic of x. So if we find the derivative of u, which is du, will be du over dx will be sine hyperbolic of x dx. So now our integration is fully u, because this is represented as u, and sine hyperbolic of x dx is now represented as du. So we have the integration will be du over u. So the integration of du over u is actually ln u, where ln u is, so we substitute u with cos hyperbolic of x. Okay, now we have solved the integration of tangent hyperbolic of x. The next step is to substitute into the interval. So I will just rewrite this, where we know that the integration of tangent hyperbolic x is ln cos hyperbolic of x. Okay, now where the interval is from 0 up to 1. So we substitute x with 1 minus ln cos hyperbolic of 0. So by using calculator, you will get the final answer, which is 0.4338.